This is a two-way analysis of variance question, SS06, June 2013, question 5. Reading through it. An oil company compared 4 different blends of petrol, so you've got 4 different blends, for fuel efficiency, using 4 different drivers and 4 different models. They were given a standard route and the miles per gallon were recorded. So miles per gallon are the observed values in the table. In order to take time away from your calculations, they've given you the sum of the squared and also T, the total sum of the observations. Easy question for the first mark. Name the type of experimental design used. You've got A, B, C, D written within the model here, so that it occurs once only in each letter occurs once only in each row and in each column. You know that's called a Latin square. Nice easy mark. Now part B has the majority of the marks, and that is completing an analysis of variance calculation. Table 4 looks like this. So it's given you some of the figures and you're asked to complete the rest of it. In order to complete the rest, we need to have the total sum of squares, and you need the sum of squares for the petrol blend. Now, the petrol blend was given as the letters in the table. Those were the letters, the petrol blend. So you're going to have to work out the sum of squares for the letters in the usual fashion. Just reminding you to check always using your tables for the formulae. So you're going to use SST quickly, and also SS, and rather than R or C, it's going to be SSL for the letters. So total sum of squares, just filling in the values in the usual way. Sum of x squared was given. That was given there. That value goes there. This value goes there. Divide by 16, and you get 217.89. That goes in there. For the petrol blend, that was the letters. You need the total for each of the petrol blends. So 121 is the total for the A's, etc. Total for B's, C's, D's. And then substituting those values into the formula for the sum of squares for the letters, sum of squares for the fuel blends. 121 squared over 4, because there were 4 values for the A's, etc. Putting those in and subtracting 2 squared over 16 in the usual way, and you get that value 65.99. Put that in the table here. So we've entered 217.89 and 65.99 there. In order to get this value, you subtract the values in this column from the total to obtain 59.56. Degrees of freedom, you do subtraction in the same way. To complete the 3, this was 4 take 1 for the degrees of freedom for the car model. 15 here because the total number of observations was 16. 16 take 1 gives you 15. You get the value here, 15 take 3, take 3, take 3 gives you 6. That's the number of degrees of freedom for the error. To find the mean square, you do the division. 14.47 divided by 3 gave you that value. So you do the same for the missing values. 77.88 divided by 3. 65.99 divided by 3. 59.56 divided by 6 gives you 9.93. Now your test statistics that you can use, the F ratio, are obtained by dividing the mean squares by the corresponding degrees of freedom. So that first value, 4.82 divided by 3. Sorry, I'm going to speaking rubbish here. I'm not thinking as I'm doing this. 4.82 divided by the mean square of the error. 4.82 divided by 9.93 gives you 0.49. This value is 25.96 divided by 9.93. I'm going to write that in there. So you did 25.96 divided by 9.93, and this value here I got by doing 22.00 divided by 9.93. Okay. Now, that is the first part of B completed. That is the calculations and table 4 completed. Now we're going to use those for part 2. Hence investigate for a difference between mean fuel efficiency for the 4 different blends of petrol and separately for the 4 different models of car, use the 5% level. So you're going to do 2 different sets of hypotheses, one for the 4 different blends of petrol, that was the letters, and one for the 4 different models of car, which is the top there. So my hypotheses are mean fuel efficiency between blends. The null hypothesis that there's no difference observed between the blends of petrol, and the alternative is that at least one mean fuel efficiency is different due to the blend of petrol. Second set of hypotheses for the car models, H0, no difference between the models. H1, there is at least one difference due to models. We've got the test statistics already in the table above. We now need the critical values. Critical value using F, number of degrees of freedom from the table, mean fuel efficiency for the blends, petrol blend, degree of freedom was 3, and the error was 6, so you're doing F36 for the degrees of freedom in the table. You want 5 per 7. If you look that up, the critical value is 4.757, and that will be for both sets of hypotheses because essentially it's the same degrees of freedom, 3, 6 for both of them. Now the test statistic from the table for the blends of petrol blend was 2.22. That's your test statistic. That 2.22 is clearly not in the critical region, so we accept H0. No difference between the blends, no difference in the mean fuel efficiency due to the blends of petrol. Same occurs with the second set of hypotheses. Your test statistic for the car models was 2.62. 2.62 is clearly not in the critical region. You accept H0, there's no difference in the mean fuel efficiency readings due to the different models. The reason I haven't put it in context at the bottom here in writing is reading the question, and you must read through the question before you actually answer each bit. It actually asks for part 3 for you to put your conclusion in the context of the question. So for part 2 I simply wrote accept H0, and then for part 3 I've written words which I've just explained. No significant evidence of a difference in fuel efficiency due to the 4 different blends of petrol. And there was no significant difference observed between the 4 models of car. Part C asks you to state all of the assumptions that's necessary to make in order to do a two-way analysis of variance. Now, you should learn the 3 assumptions. There are 3 marks, and you will have in your notes and in your heads the words normally distributed, common variance, and no interaction. Can you be aware that they will only give you the mark if you put those 3 reasons in context? So you must write that the fuel efficiency measurements, you can even be more specific than that and say the miles per gallon measurements are normally distributed. You have to say it's the measurements or the observations in the table come from a normally distribution, a population that's normally distributed. The common variance for the measurements within each group. There has to be a common variance for the measurements for each group. And lastly, there must be no interaction, no association between the different factors. In this case, petrol blend, car model, and driver. That completes question 5.